Hello, my name is Daniela Castillo Espina. In this video, I will explain what an operational amplifier is and is not inverting, subtractor, and weakened sound configuration. We will go over how they work, their application, equations. Let's get started. Thank you. You will say, what is an operational amplifier? Okay, let's go. An operational amplifier, or simply Opam, is an integrated circuit designed to amplify electrical signals. It has two inputs, an inverting and a non-inverting, and an output that depends on the voltage difference between the inputs. Its symbol is a triangle with three terminals and is used in a variety of applications, such as filters, oscillators, and signal amplifiers. Okay, in the non-inverting configuration, the gain equation is obtained by dividing RF by R1 and adding 1. Then this result is multiplied by Bain. Since the current of Bean is 0 because it is connected to vertical ground, the current flows throughout RF and finally exits throughout Bout. Let's not forget to always know where the current is going. See the flow directions, connect red line, and consider the position of ground to avoid mistake. In the equation, we can see that we work with resistances on one side of the subtraction of the input. Let's look at an example with two resistances, R1 as 100 kΩ and R2 as 200 kΩ. Since the current at the ground point is 0, the current flow and exit through the out. The substrate amplifier allows us to obtain the difference between two input signals. This is achieved by connecting the input to a resistor network in bridge configuration. Finally, the weighted summing amplifier allows us to assign multiple input signals with different weight. Each input passes through a different resistor before reaching the inverting input of the Opam. The output voltage equation is in weighted summing amplifier. We can have as many resistors as we want since it's in summing circuit. Using the superposition method, we analyze the contributions of each input separately. We write the equation, and this case Rx is the same for all inputs. I chose to set it to 200 kΩ and apply it to the formula. Since we have three resistors, three inputs, the result is an achieved, which gives a factor of 1/3.
Okay. For the step-by-step with the simulations, we have to look for simulations, which is of the one inverting configuration. We're in the section where it says place analog. We look up the LM 749H/883. We look for the operational amplifiers. But we have to take into account the power supply, which is with two voltage accounts in this part. Which is with two voltage counts, DC power, 2, 15 voltage. And where are the top and the positive part? And in the positive part, it is plus VCC, with the on the bottom negative part, it's VSS. And this part on the middle of this, on this two, it's go aligned. In this part, ground, connected to the two voltage counts. And this is the power supply. In order to have an internal connection, you have to do the same procedure in the operational amplifier. Okay, on pin 7, you have double click and set close VCC. And on pin 4, double click again and set BASS. For the non-inverted configurations, the input voltage vein and shared through and uh, the positive and through the negative. There is a resistance that connected to the ground, and there is a second resistors to connect the output voltage or the out. Okay, and the negative. The negative port, the ground, and the out, and the resistance. And for example, if we want a non-inverting configuration with the gain 90, we can set the resistor 2 to 10,000 ohms, um, 10,000 ohms, and the resistor 1, 1,000 ohms. But for this, we must take an oscilloscope into account. The oscilloscope is in this port, um, and where we must have a sinusoidal signal in this port and AC power, preferably 1 volts with the amplitude and 17 HP. No, 1 volt, 17 or 16. It's good. We've connected this. Um, we've connected this. The port positive with A. It connected with the positive part with the LMC 739. The parts, the negative parts, and the ground. Okay, in the negative parts, the grounds, and the positive part with the sinusoidal. We connected with the positive part with the amplification LM 739 and the negative part in the ground. Okay. And the positive part with the V in V out. This. Okay, so if we put it on into account the voltage in this graphic, the output the equation, which is V out over V in, is equal to 1 plus resistance 2 over resistance 1. Um, resistance 2 is 10,000 ohms over resistance 1 1,000 ohms. We observed we I move this line and 10 okay and with I move this line in the second channel it's the voltage 10.959. It's approx 11. When this voltage appears, which is an approximation, and we can see the input and output wait in the negative port in the second channel. And this is the first configuration. Okay, now the second configuration we have is a substrate, which one of the positive sides. The side consists of two resistors, one with a voltage source, okay, and another connected to the ground. And the two resistance uh, connected in series. Connected in series. Um, and in the negative side, a resistor is connected to a voltage source. This is V. and two voltage surge in ground. And, ground. And this resistor connected with a negative port and in Vout. Okay, what this does is that it divides the resistance to, um, resistance to, it is this, and it is this. Um, by resistance 1, is this, and is this. And multiplies the subtractions of the two input voltage, this and this, and we can see. And this will have to give us 4 because 2 divided by 1 by gives 2 and multiplied by 3 less 1 will have 4 as we can see and as we can see this port voltage this port and play run 4 voltage because these operations and it's true because and and king and this is a Twitter embedded summation the three configuration and where is this function is average the values according to your equation uh, and where each voltage is a node. Three is 3 voltage, and the first node is 5, the second is 4, the three node is 3, and each resistance is a percentage. The percentage with the first node is 33,000. The second percentage with the second node is 33,000 ohms, and the three percentage with the three node is 25,000 ohms. Where the resistance Rx is what it is the novel's resistance. Yeah, because the equation is this. Okay, the 3 voltage it's connected in if a ground. The resistance connected with this voltage. Um, the positive port is connected with a ground, and the negative port is connected with the resistance. The resistance Rx is connected with the negative port and in the Vout. Okay, so we can see that this equation, uh, Rx is R4, 10,000 about uh, resistance 1, 33,000 ohm. Multiplied with V1, the voltage 1 is 5 volts equals Rx 10k ohms, 1000 ohms, about 33, about 33, 33. Multiplied with voltage 2, it's 4 voltage plus Rx is 10,000 ohms, um, about 25,000 ohms. And this, so that should give 3.92 volts. We can verify that in fact it gives this port this and later in effect 3.92 volts. This part is negative, but it can be multiplied by inverting configuration to make it positive, and this is true. And the voltage ins and the V out is